Hi everyone, welcome to PharmaGrid. So today we are going to discuss some pharmaceutical calculations. So starting with the first question, how much potassium chloride having molecular weight 74.6 would be required to prepare 1 liter of an intravenous solution to be infused into a patient continuously over a 6-hour period at the rate of 0.10 millimole potassium per minute. So in this question, we need to find out the amount of potassium chloride required to prepare 1 liter of an intravenous solution, and it should be infused into the patient for a period of 6 hours, and the rate is given in millimoles, that is 0.10 millimole potassium per minute. Okay, so these are all the data given in this particular question. We know that a mole is the molecular weight of a substance in grams. So what will be millimole? It is the 1000 of a mole. That is molecular weight of a substance in milligrams. So here the rate is given as 0.10 millimole potassium per minute. So the equation for millimole is equal to weight in milligram divided by molecular weight. Millimoles we already know, that is 0.10. Molecular weight is 74.6. So substitute all these values in this equation. We will get the value as 7.46 milligram. It is the amount of potassium chloride that to be infused in 1 minute. See, the rate is given in 1 minute. But we need to find out the amount that to be infused for a period of 6 hours. Okay, so we know for 1 minute. So how we will calculate for 6 hours? We know that 1 hour is equal to 60 minutes. So for 6 hours, weight of this potassium chloride in milligram, that is 7.46 into 60 into 6, that is equal to 2685.6 milligram. So convert this into gram. We will get it as 2.68 gram. So here the correct answer is option B, which is the amount of potassium chloride that is required to prepare 1 liter of an intravenous solution that to be infused into a patient continuously for a period of 6 hours. The next question, how many millimoles of sodium are present in the following mixture? Sodium citrate 1 gram having molecular weight 294.1, sodium carbonate 800 milligram, molecular weight 106, red syrup 1 ml, concentrated chloroform water 0.25 ml, purified water to 10 ml. So here we need to find out the total number of millimoles of sodium present in this following mixture. So in order to find out this, we need to calculate the number of millimoles in sodium citrate and number of millimoles in sodium carbonate, and we need to add these values together. Okay, so first of all we need to find out the millimoles of sodium present in sodium citrate. It is given as 1 gram and the molecular formula is given, molecular weight is equal to 294.1. So the equation for millimoles is equal to weight in milligram divided by molecular weight. Here weight is given in gram, that is 1 gram. So convert this into milligram. We will get it as 1000 milligram divided by molecular weight is 294.1. So substitute these values in this equation. We will get it as 3.4 millimoles of sodium citrate. But see the structure here. In this sodium citrate, it consists of 3 atoms of sodium. Okay, so multiply this value with 3, that is 3.4 into 3, that is equal to 10.2 millimoles of sodium. It is the amount of or the number of millimoles of sodium present in sodium citrate. Next, find out the number of millimoles of sodium present in sodium carbonate 800 milligram having a molecular weight of 106. Millimoles equal to weight in milligram divided by molecular weight. Here the weight is already given in milligram, so no need to convert this value. So 800 divided by 106, that is equal to 7.54 millimoles of sodium carbonate. Also see the structure here, that is Na2CO3. So the sodium carbonate consists of 2 atoms of sodium. So multiply this 7.54 by 2, that is equal to 7.54 into 2 is equal to 15.1 millimoles of sodium. So this is the total number of millimoles of sodium present in sodium carbonate. So now we can find out the total millimoles. Total millimoles equal to this 10.2 millimoles of sodium that is present in sodium citrate plus 15.1 millimoles of sodium present in sodium carbonate, that is equal to 25.3. So here the correct answer is option E, that is 25.3. It is the total number of millimoles of sodium present in this mixture. Next question, how much ferrous sulfate having molecular weight 278 would be required to prepare 100 ml of a concentrated solution such that when 5 ml is diluted to 250 ml yields a 0.1 millimolar solution. So in this question, the strength of millimolar solution is given as 0.1 and we need to find out the amount of ferrous sulfate required to prepare 100 ml of a concentrated solution. And the given clue is that 5 ml diluted to 250 ml yields a 0.1 millimolar solution. So the equation for millimolar, in order to find out the millimolar concentration, is equal to weight in milligram divided by molecular weight per liter of the solution. So the strength of millimolar solution we know, it is 0.1 and the weight in milligram we don't know, take it as x, divided by molecular weight is 278 per liter, liter is 1. So substitute all these values in this equation. Find out x. X is equal to 0.1 into 278. That is equal to 27.8 milligram. So this is the amount of ferrous sulfate present in 1 liter of the solution. That is 1000 ml of the solution. Now we need to find out the amount present in 250 ml. Okay, so we already know the amount present in 1000 ml, that is 1 liter. Now we can find out the amount present in 250 ml, take it as x. So find out the value of x by cross multiplying, that is 250 into 27.8 divided by 1000. That is equal to 6.95 milligram. So 6.95 milligram of ferrous sulfate is present in 250 ml of diluted solution. So see the question here. 5 ml diluted to 250 ml. So on dilution the strength will not change. Okay. So this 6.95 milligram of ferrous sulfate will be present in 5 ml of undiluted solution. Now we need to find out the ferrous sulfate present in or ferrous sulfate required to prepare 100 ml of the concentrated solution. So we know the amount present in 5 ml of undiluted solution, so that we can find out the amount present in 100 ml. So take it as x or y. So find out the value of x by cross multiplying, that is 6.95 into 100 divided by 5, that is equal to 139 milligram. So here the correct answer is option D, that is 139 milligram. Next question. How many milliosmoles are contained in the following solution? Disodium hydrogen phosphate 2 gram, molecular weight 358.1. Potassium dihydrogen phosphate 1 gram, molecular weight 136.1. Purified water 200 ml. So in this question we need to calculate the milliosmoles. So the equation to find the same is weight in milligram divided by molecular weight into number of species. So let's first take the case of disodium hydrogen phosphate. So it is given as 2 gram and molecular weight 358.1. So how to calculate the number of species here? Here the molecular formula is given as Na2HPO4. So we can write it as 2Na plus HPO4 minus. So this molecular formula consists of 2 atoms of sodium and hydrogen phosphate. Okay, so the total number of species will be is equal to 3. So substitute the values in this equation. Weight in milligram will be equal to 2000 milligram because here weight is given in grams. Convert it into milligram. So 2000 divided by molecular weight is 358.1 into number of species, that is equal to 3. So we will get the number of milliosmoles as 16.76. Next, take the case of potassium dihydrogen phosphate. It is given as 1 gram and molecular weight 136.1. So substitute the values in this equation. That is 1 gram means 1000 milligram divided by molecular weight is 136.1 into number of species. So here number of species will be is equal to 2 because KH2PO4 can be written as K plus plus H2PO4 minus. Okay, so there will be 2 number of species. So multiply by 2, that is equal to 14.69. So in order to calculate the total milliosmoles contained in the following solution, add these 2 milliosmoles, that is 16.76 plus 14.69, that is equal to 31.45. So here the correct answer is option A, that is 31.45 milliosmoles. So the next question, the number of milliosmoles contained in the following solution is magnesium chloride, molecular weight 203.3, 12 milliequivalent, potassium chloride, molecular weight 74.6, 20 milliequivalent, water for injections to 100 ml. So here we need to calculate the number of milliosmoles. But one twist is here that here the weight is given in milliequivalents, okay, not in grams. Okay, so in order to calculate the number of milliosmoles, first of all we need to calculate the weight in milligram. Okay, so We know the equation to calculate the milliequivalents, that is equal to weight in milligram divided by molecular weight into valency. So first take the case of magnesium chloride. We know milliequivalents, number of milliequivalents is equal to 12. Molecular weight is given as 203.3. And what about the valency? Valency is 2. Okay, magnesium chloride can be written as Mg2 plus plus 2Cl minus. Okay, so here the valency of magnesium chloride, magnesium is 2. Okay, so substitute all these values in this equation. So we will get the weight in milligram as 1219.8 milligram. Okay, now substitute this in the equation for milliosmoles, that is equal to weight in milligram divided by molecular weight into number of species. Weight in milligram we already got here, that is 1219.8 milligram divided by molecular weight is 203.3 into number of species. In magnesium chloride, number of species is equal to 3. How? Because magnesium chloride can be written as Mg2 plus plus 2Cl minus. Okay, so it consists of 1 atom of magnesium and 2 atoms of chlorine. So total number of species is equal to 3. So multiply this value by 3, we will get it as 18 milliosmoles. Now do the same in case of potassium chloride as well. It is given as 20 milliequivalents having molecular weight 74.6. So first substitute in the equation for milliequivalents. So milliequivalents we already know it is 20. Then weight in milligram we don't know. So take it as x divided by molecular weight is 74.6 into 1. 1 is the valency. That is in potassium chloride the valency is 1. So we will get it as 1492 milligram. So the weight in milligram we got. Now substitute this value in the equation for milliosmoles. Milliosmoles is equal to weight in milligram divided by molecular weight into number of species. Weight in milligram is 1492 milligram divided by molecular weight is 74.6 into number of species. Number of species is 2. This potassium chloride can be written as K plus plus Cl minus. So it consists of one atom of potassium and 1 atom of chlorine. So total number of species is equal to 2. So multiply this value by 2, we will get it as 40 milliosmoles. So we got the number of milliosmoles contained in magnesium chloride and potassium chloride. So the total number of milliosmoles contained in the solution will be adding these two values, that is 18 plus 40. That is equal to 58 milliosmoles. So here the correct answer is option B, that is 58. So with this question we have completed today's question discussion series, calculation series. Thank you everyone for watching this video. Please like, share and subscribe. Have a great day.